Hi guys, this is going to be a video about single replacement reactions. And so single replacement reactions generally tend to happen when you have a metal and some sort of salt. Okay, and so it's a single replacement reaction because there is only one replacement in the reaction, right? So the general form for a single replacement reaction is you have some sort of metal, so I'll call it metal 1, and then metal 2, right? So we have some sort of free metal reacting with a salt. And what happens is metal 1 kicks out metal 2. Okay? Metal 1 kicks out metal 2. And so what we're left with is just metal 2. So the free metal 2 plus now metal 1 with the anion still there. Okay? So that's the general form. And so the way metal 1 kicks out metal 2 is metal 1 has to have a greater activity than metal 2. Okay? So the activity of metal 1 has to be greater than the activity of metal 2. Okay? Activity is just a fancy way of saying I'm more reactive. Okay, I'm more reactive. And so in solution, we have all sorts of different activities for the metals. And so where you can look on the chemical information sheet is looking at the activity series. Okay. Elements at the top of the activity series are more active than elements at the bottom of the activity series. Okay. So free metals, such as cesium, rubidium, potassium, they have the ability to replace ions in solution. Okay? And so you need to figure out, all right, what's the free metal and what is it replacing? Okay? So for example, if we had zinc metal reacting with copper 2 chloride in solution, well, we have to figure out, can zinc replace copper, right? Is the activity of metal 1, that is zinc, greater than the activity of metal 2, that is copper? So the way we do that, we look at the chemical information sheet. We're going to look for zinc. Okay, zinc is the free metal, so we're going to look for that first. Zinc is up here, and if we scroll down, copper is all the way down here. So between zinc and copper, well, zinc is higher than copper on the activity series. So zinc is more active than copper, which means this reaction can happen. This reaction does happen. Zinc kicks out the copper, and so what it does is it leaves free copper metal, and then you need to figure out the ion, right? Zinc will form +2 ions in solution, and it's a good idea to check this ion table over here because the ions related to transition metals can change, right? So zinc replaces copper, so you're left with copper metal plus zinc chloride. Okay, that comes from zinc 2 plus, chlorine minus, right? To balance it out, you get that. Okay, so zinc plus copper chloride will give you copper plus zinc chloride. All right, let's try another example. Let's say we had gold metal plus cesium chloride. Right, so now we have to figure out, all right, is gold more active than cesium? So the free metal, gold, if we look on the activity series, it's right here. Cesium is going to be up here. So gold is way below cesium in the activity series. So what does that mean? That means that this reaction does not happen. No reaction. Because gold is not more active than cesium, gold cannot kick these ions out of solution. Okay, cesium is hogging it all for itself, so gold can't really do that. In fact, gold is one of the worst elements for single replacement reactions, which makes it very chemically stable. Okay. Let's do one more reaction, right? So let's say we had chromium metal plus iron chloride, iron 3 chloride, right? So chromium is here, iron chloride, iron 3 chloride is up here. So we got to figure out, all right, well, chromium is higher than iron, so it can happen. So this does kick it out. So we're left with iron metal plus chromium chloride. And if you noticed, chromium had two different options here, right? In reality, what will happen is it will form both options. It will form the +3 salt and the +2 salt, right? It's a little complicated to do that. So when in doubt, just I guess choose the highest or choose whatever, makes sense. So since this was a 3+ ion here, it's probably going to kick it out and form another 3+ ion. Okay. All right. Take care, everyone.